TEK 3A is in the linear category, and it's the first slope TEK. It says that the student is expected to determine the slope of a line given a table of values, a graph, 2 points on the line, and an equation written in various forms, including slope-intercept form, standard form, and point-slope form. So what we're talking about here is the slope of the line, the incline of the line, how its steepness is. We calculate these in different ways, but the most basic way is using the slope of a line formula that's found on the student's formula chart, which is the slope, or the slope since it's the letter M, y2 minus y1 over x2 minus x1. Other ways to talk about this is the change in the y's over the change in the x's, the rise over the run, or how much I go up and down and how much I go side to side, up and down and to the right. So when we're given a table of values, we want to fill in that slope formula. So what we would do is write down our formula from our formula chart and find a first and a second x from my table, as well as a first and a second y from my table. Those are the numbers I'm plugging into this formula. So y2 is 8.5, I'm going to subtract 10 from that. And then x2 is -1, I'm going to subtract -2 from that. Throwing it into a calculator or doing this in your brain, minus and negative is really like adding. So I have 8.5 minus 10, that's -1.5, and -1 plus 2, that's a +1. So my slope here will be -1.5, or the fraction -3/2. And with slopes, we're going to want the answers in fraction form because they tell me a physical rise and run number. From a graph, we're going to use the slope idea. I could still use the formula that's on the formula chart because I can still find coordinate points and plug it into the formula. But if I want to use the rise and the run, I'm going to figure out how much my graph has changed from the first point to the second point. Well, my graph has gone down 1, 2, 3, down 3, down is a negative number, and my run to the right is 2. So then again, I've calculated that my slope, my slope, is -3/2. Same way. That's the incline of the line. And last, one of the other ways we're going to give it to them is from 2 points on a line. This looks exactly like a table, except when I'm labeling these points, they're not combined together by x's and y's, they're in coordinate pairs. Oh, I just wrong thing. The first coordinate pair is going to be x1 and y1. The second coordinate pair is going to be x2 and y2. I still know exactly where to put these in my formula. y2 is 4, y1 is 7, x2 is 2, x1 is 0. 4 minus 7 is -3, 2 minus 0 is 2, and I still know that my slope is -3/2. It's not always going to be -3/2. I picked the same function to show you in various forms that it's all the same idea, found in different ways when we're given different information. And then we could give you an equation. Now there are plenty of equations we use in this class. When we're dealing with linear equations, we have 3 main ones. You have standard form, which is alphabetical order. You have slope-intercept form, mx plus b. And you have point-slope form, which uses a point and a slope. There's other videos that talk exactly about these equations, so you'll find those later. But when we have these forms, we want the m because m represents my slope. So in 2 of the 3 forms, I can just look at it and figure out the slope. There's the m because it's next to the x. It's not the x, it's next to the x. And here's the m because it's in the same spot in point-slope form. Now standard form, there's no m in this equation, so I can't just look at it and know what it is, but there's a short formula for standard form that we can use. It's the opposite of a divided by b. So whatever number is in front of a, we're going to use the opposite. So here's -3, and we're going to divide it by b. -3/2. And then it's the same slope, just like the other equation. These are all equivalent, just different forms. Now these are some of the visual aids you'll see this year. This visual aid actually doesn't look like this. Sorry, this looks like this. Where you either have up or down, or we're going to the right. But these are some of the things your students might be able to see on a formula chart that's going to help them remember how to talk about slope. This is the number 1 that they're going to be able to use because it's definitely given on a formula chart at all times in this class, the slope formula. So an example question taken from a STAR test is, what is the slope of a line that passes through these 2 points? Well, this is just like what we had before. We look at our formula chart, and we know that the slope of the line is a whole formula that's on my formula chart. All I have to do is put the pieces where they belong. So if I label my points correctly, there's the first set of coordinates. There's the second set of coordinates. I'm going to be able to put these pieces where they belong in this formula. y2 is 12, y1 is 7, x2 is negative 39, x1 is 26. 12 minus 7 is 5. Negative 39 minus 26 is 67. Oh, negative 67. But that's not an answer choice. I do have to reduce my answer choice here. So when I reduce, yep, that's right. When I reduce this, I'm going to get negative 1 over 13. Yes, that is correct. What is the slope of the line represented by this coordinate? Okay, well this is standard form. Remember, this is not the version that I can just look at it and know the slope. I have to remember that my slope from standard form is the opposite of A divided by B. It's the only way to find my slope formula from standard form, unless I want to solve the equation for y and figure out what the m is, which is a lot of work that we don't have to do. Well, A is 5, so the opposite of 5 is negative 5, and B is a negative 12. So I know my slope is going to be negative 5 over negative 12. Well, that reduces to 5/12. And there I have the slope of this line. I could always throw this in a graphing calculator and see what the line looks like and count my rise and run to identify that it's 5 and 12 between 2 good points. Rise of 5, run of 12. As always, remember, we empower, we impact, we love. We are Skeeter Nation.